In this lecture, you will understand modulators that are used for the generation of the DSB-SC modulated signal. DSB-SC modulated signal or double sideband suppressed carrier signal contains upper sideband signal and lower sideband signal. Here the carrier signal is suppressed and it is not transferred during the transmission of the modulated signal in order to save power and increase the efficiency compared to amplitude modulation. This DSB-SC modulated signal can be shown in the frequency domain as here there are two sidebands or USB and LSB on the both sides, but the carrier signal is suppressed. There are basically two types of modulators that can be used for the generation of the DSB-SC modulated signal, and they are balanced modulator and ring modulator. Let us see how the balanced modulator can be used for the generation of the DSB-SC modulated signal. Balanced modulator. Balanced modulator is a modulator that uses two identical AM modulators for the suppression of the unwanted carrier signal. So by using balanced modulator, the unwanted carrier signal in the amplitude modulated signal can be suppressed, or this modulator can generate the DSB-SC modulated signal. Let's see the block diagram of the balanced modulator. In the block diagram of the balanced modulator, modulating signal MT and carrier signal CT generated by the local oscillator are given as the input to the balanced modulator. At the output of the balanced modulator, the DSB-SC signal is produced with the carrier of the amplitude modulated signal being suppressed. Hence, the output of the modulated signal is consist of upper and lower sidebands only. The principle of operation of a balanced modulator states that if two signals at a different frequency are passed through a nonlinear resistance, then at the output we get an amplitude modulated signal with suppressed carrier. The device having the nonlinear resistance can be a diode, a MOSFET, or even a bipolar transistor. Types of balanced modulator. Based on the use of nonlinear device, the balanced modulator can be constructed in three different ways for the generation of the DSB-SC modulated signal. Hence, the balanced modulator can be classified as balanced modulator by using diode, balanced modulator by using FET, and simple AM balanced modulator. In this lecture, we will understand what is diode balanced modulator and how the diode balanced modulator functions to generate DSB-SC modulated signal. The diode balanced modulator. Double sideband suppressed carrier system or DSB-SC system is an amplitude modulation technique in which modulated signal contains both the sidebands along with the suppressed carrier. Conventional amplitude modulation is consist of two sidebands and a carrier signal where the major part of the transmitted power is concentrated in the carrier which contains no information. Thus, to increase the efficiency of transmission and to save power, the carrier signal is suppressed in the DSB-SC system. The DSB-SC generation using balanced modulator is based on the nonlinear resistance, and the DSB-SC balanced modulator by using the diode is based on the characteristics of the diode. The diode in the balanced modulator uses the nonlinear resistance property for producing the modulated signals. Let's see the block diagram for the modulator circuit. The modulating signal is applied as an input to the primary of the transformer T1, whose secondary is center tapped with the ratio 1:2. The center tapped secondary side of the transformer T1 generates two modulating signals. This generated carrier signal is given as an input to the center taps of the input transformer T1. Now, modulating signal and carrier signal are combined together as voltage V1 and voltage V2 and given as inputs to the diode D1 and D2 respectively. The modulating signals or message signal at the inputs of the both of the diodes are in 180 degree out of phase from each other. The two diodes D1 and D2 produces the currents I1 and I2. The output currents of the two diodes flows through the resistor R and produces the voltage V3 and V4. As the currents are opposite to each other and net voltage V0 across the LC bandpass filter is the subtraction of the voltage V3 and V4, the net voltage V0 contains two sidebands and a modulating signal term. Due to the LC bandpass filter, this modulating signal term will be eliminated and the two sidebands will be allowed to pass through, and finally we will get the DSB-SC modulated signal at the output. Let's see the mathematical analysis for the balanced modulator by using diode. In the block diagram, the modulating signal and the carrier signal are combined together and given as an input to the diodes. So, input voltage to the diode D1 is given by V1 is equal to Ct plus Mt, where Ct is the carrier signal and it is represented by AC cos omega Ct. Identify this equation as equation number 1, and the input voltage to the diode D2 is given by V2, which is equal to AC cos omega Ct minus Mt. And identify this equation as equation number 2. Now, the diode current flowing through the diode D1 is nonlinear in nature, and the diode current through the diode D1 or I1 is equal to AV1 plus BV1 square, where A and B are constant. If we put the value of B1 from the equation number 1, then I1 is equal to A into AC cos omega Ct plus Mt plus B into AC cos omega Ct plus Mt whole square, which can be simplified as I1 is equal to A into AC cos omega Ct plus A into Mt plus B into AC square cos square omega Ct plus 2 into B into Mt AC cos omega Ct plus B into M square T. Identify this equation as equation number 3. Now, the current that flows through the diode D2 also follows the nonlinear characteristics of the diode, so I2 is equal to A into V2 plus B into V2 square. If we put the value of V2 as AC cos omega Ct minus Mt from the equation number 2 in the equation of the I2, then I2 is equal to A into AC cos omega Ct minus Mt plus B into AC cos omega Ct minus Mt whole square. By simplification, I2 can be written as A into AC cos omega Ct minus A into Mt plus B into AC square cos square omega Ct minus 2 into B into Mt AC cos omega Ct plus B into M square T. Identify this equation as equation number 4. The output currents of the two diodes D1 and D2 flows through the resistor R and produces the voltage V3 and V4. So the voltage V3 is equal to current through the diode D1 or I1 into R, or if we replace the value of I1 from the equation number 3, then the equation of voltage V3 looks like this. Identify this equation as equation number 5. Now, the voltage V4 is equal to diode current through D2 or I2 into R, and if we replace the value of I2 from the equation number 4, then the voltage V4 looks like this. Identify this as equation number 6. Now, the net voltage V0 is the subtraction of the voltage V3 and V4. After performing this subtraction, V0 is equal to 2A into Mt plus 4B into Mt into AC cos omega Ct into R. If we replace Mt by Am cos omega Mt, then the equation of net voltage V0 becomes 2A into Am cos omega Mt plus 4B into Am cos omega Mt plus into AC cos omega Ct into R. Now, if we take 4B by 2 common from the second term, then equation of net voltage V0 is equal to 2A Am cos omega Mt plus 4B by 2 into 2 into Am cos omega Mt into AC cos omega Ct into R. If we apply the formula of 2 cos A cos B in the equation, then the net voltage V0 is equal to 2 into Am into cos omega Mt plus 4B into Am into AC divided by 2 cos omega C minus omega M into T plus Am into AC divided by 2 cos omega C plus omega M into T into R. Now, if we multiply R with every terms, then the net voltage V0 is equal to 2A R Am cos omega Mt plus 4B R Am into AC divided by 2 cos omega C minus omega M into T, 4B R Am into AC divided by 2 cos omega C plus omega M into T. Let's say 2AR Am is equal to P and 2BR Am into AC divided by 2 is equal to Q. Then net output voltage V0 is equal to P into cos omega M into T plus 2Q into cos omega C minus omega M into T plus 2Q into cos omega C plus omega M into T. Identify this as equation number 7. This output voltage contains 3 terms. Here first term is P into cos omega Mt, second term is 2Q into cos omega C minus omega M into T, and the third term is 2Q cos omega C plus omega M into T. Second and third terms act as two sidebands and they combine to produce the DSB-SC modulated signal. Here first term is a modulating signal term, and second term is a lower sideband, and the third term is a upper sideband. By using LC bandpass filter, the modulating signal term can be eliminated. So finally, the net output voltage V0 is equal to 2Q cos omega C minus omega M into T plus 2Q cos omega C plus omega M into T Thus, the diode balanced modulator produces the DSB-SC modulated signal at its output. That's all for this lecture. If you have any doubts regarding this lecture, then you may ask it in the comment section, and don't forget to hit the subscribe button, and see you in the next one.